Now that you're all pros at naming ionic compounds, we're going to take things one step further, and we're now going to name what are called polyatomic ions, and we're going to write their formulas too. So first thing you might need to know is what the heck is a polyatomic ion, and basically what it is, it's just like this cluster of ions that travel together as a group. Okay, you can't separate them apart, they just come together as a package deal, and overall, all these things combined have one overall charge, as if they were just a singular ion, but they're not. There's several of them together. And you might be like, what? Okay, so probably a lot of you have heard of cyanide. Okay, cyanide is a polyatomic ion. It's Cn. So a carbon and a nitrogen are together. They travel together. You can't separate them apart. They're their own little buddy group. Okay, and they come together. And when carbon and nitrogen come together, they overall have a charge of -1. You don't need to know how or why they have a charge of -1. That's not a thing that you need to know or figure out. It's a thing that I'm telling you. They have a charge of -1. Okay, so we're going to take this now and apply this to what we did last time. If I've got a compound that's called KCN, what's the name of it? Well, K stands for potassium, and Cn stands for, as I just told you, cyanide. So it would be potassium cyanide. Now, one thing you might say is, well, how do I know it's not potassium carbon nitrogide? Well, that's not a thing. And basically, whenever you see a metal and something that isn't just a nonmetal here we've got two nonmetals, your brain automatically should go to, oh, this is funky, this must be a polyatomic ion. Okay, whenever you see more than two elements in a formula, you know you're dealing with a polyatomic ion. Okay, and with the polyatomic ion, okay, the first thing, the metal stays the same. Most of the ions are negatively charged, they're anions, so they're almost always going to be the second thing in your formula. Okay, and so this would be like a thing that you're going to have a sheet of, and you would just look it up on your sheet. Okay, and Cn is cyanide. So in this case, we wouldn't need to change the ending, but as it turns out, on none of them do we change the ending. This is different from naming regular ionic compounds where we drop the ending and add IDE. Nope, you keep both names as is. K is potassium, Cn is cyanide, the name is potassium cyanide. We don't mess with either of the names, okay? Let's look at another one, lithium cyanide, okay? If we're trying to write the formula here, right, because last time we were just naming it, KCN is potassium cyanide. Okay, what if I'm trying to write the formula here? Well, we're going to follow the same steps as last time. So I'm going to write up my ions. Lithium is +1. Cn, remember, it's that little bundle. It has a charge of -1. And so my charge is balanced, +1, -1. And so lithium cyanide would be LiCn, just like that. Let's look at another polyatomic ion, peroxide. Maybe you've heard of hydrogen peroxide, right? We use them in our demos, used in first aid. If you have a cut or something, you might use hydrogen peroxide to clean it. If you've gotten your ears pierced, you might be able to clean your ears with hydrogen peroxide afterwards. So let's look at trying to write the formula of hydrogen peroxide. I'm going to write out my ions. Hydrogen is in group 1, it's +1. Peroxide, I told you right here, is O2, and it has a charge of -2. So that's why I have this O2 and -2 here. Notice my charges don't balance. I got a +1 and a -2, so that's not going to work, okay? So I'm going to need 2 +1s. I'm going to need 2 hydrogens to balance out this peroxide. So to write that formula, then I need H2 because of my 2 hydrogens, and then peroxide comes next, which is O2. So hydrogen peroxide's formula is H2O2. Here's one more example. Bromate is another type of polyatomic ion, and it is BrO with a little subscript of 3 behind it. Okay, and this whole cluster, this BrO3, the whole thing has a charge of -1. Okay, so if I wanted to know the formula for calcium bromate, again, I'm going to write down my ions. Calcium is in group 2, so it's +2. Bromate, we just learned, is BrO3, and the whole thing has a charge of -1. And so +2 -1, that doesn't balance out. And so I'm going to need 2 of these bromates, 2 of these -1s to balance out this +2. And so the way I would write that is Ca parentheses, put my bromate in, and my parentheses in, and then put a little 2 behind the parentheses, meaning that I have 2 of this whole cluster. okay? I cannot do BrO3 and then a 2 next to it because, like, is that a 32? And we wouldn't put an O6, okay, because it's two of these bromate clusters. And so the way to show that we want two clusters is we got to put parentheses around the cluster and then put, in this case, a 2 behind it. Okay, so that's the only thing here with polyatomic ions, is if you need more than one polyatomic ion, you have to put parentheses around it. Like I said before, you're going to be given a list of some common polyatomic ions that we'll be using in class. It'll have their name, it'll have their formula, it'll have their charge. You will never, ever, ever have to memorize any of these things. You'll get pretty familiar with some of them, so you might start to recognize them and not need to look them up, but you will never be required to memorize them. You will always have the sheet with you. It'll live in your binder. You'll use it all the time. And then if you've got a quiz or something, you can always use this sheet on your quiz. Okay, and don't worry, we're going to be doing plenty of practice in class, naming polyatomic ions and writing their formulas coming up really soon.